extend the power rule to functions with rational exponents. So for our first example, we're going to look at 4 expressions with rational exponents. And we can see that all these expressions have rational exponents because they all have fractions as powers. Now, to take the derivatives of fractional exponents, we're just going to use the normal power rule as usual. So to find the derivative of negative x raised to the 1/2 power, we're just going to take the exponent, multiply it to the coefficient, and subtract 1. So that's going to give us negative 1/2 x raised to the 1/2 minus 1 power, which can be simplified to be negative 1/2 x to the negative 1/2 power. And we can actually leave it like that. If you would want to rewrite this expression to get rid of the negative exponent, you're more than welcome to, but it's not required. All right, moving on to letter B, we have 4 times x to the 5/2 power. So again, we want to take the derivative of this expression. And to use the power rule, we're going to take the exponent, multiply it by the coefficient, and subtract 1. So let's see, 4 times 5/2 is going to be 20 halves, and then x to the 5/2 minus 1 power. 20 divided by 2 is 10. 5/2 minus 1 ends up being 3/2, so our derivative will be 10x to the 3/2 power. Moving on to letter C, we want to take the derivative of negative 4/5 x to the 3/2 power. So that means we're going to take the exponent, multiply it to the coefficient, and subtract 1. Now we need to wait for my writing to catch up. Let's go, let's go, let's go. And there we have it. All right, so what do we got? We got 3/2 times negative 4/5, so that'll be negative 12/10 x to the 3/2 minus 1. And then negative 12/10 can simplify down to be 6/5 x to the 1/2 power, because 3/2 minus 1 is 1/2. And then finally, letter D, we want to come in and take the derivative of 5/3 x to the negative 4/3 power, and just like the other 3, multiply the exponent by the coefficient and subtract 1. So this is going to simplify to be, let's see, negative 5/3 times negative 4/3 will be negative 20/3 x to the negative 4/3 minus 1. We can't simplify negative 20/3 at all, so we'll leave that alone. But negative 4/3 minus 1 is negative 7/3. All right, and there you have it. We can see that we can just apply the power rule as normal if we have a rational exponent. All right, so next up, we're being asked to find the derivative at a specific point. So what is the derivative of f of x equals negative 4/3 x to the negative 5/2 at the point x equals 4? All right, so first we're going to need to come in and find the derivative. So to take the derivative, we're going to take the exponent, multiply it by the coefficient, and subtract 1. So therefore, f prime of x is going to be negative times negative is positive, 4 times 5 is 20, 3 times 2 is 6, x to the negative 5/2 minus 1. Which, let's see, we can simplify to be 10/3 x to the negative 7/3. So there's our derivative, but we don't want to find the general derivative. We're looking for the derivative at a specific point. So we're trying to find f prime of 4, which means we just need to plug 4 in for x. And then from here, I'm going to use my handy-dandy calculator to do the heavy lifting for me. So 10/3 times 4 raised to the negative 7/3 power is going to end up being 0.1312, and we'll just leave it as is. If you do get a decimal Newton, they will give you directions on how far they want you to round it, but since I don't give you any directions here, we'll just round it to 4 decimal places. Now, using the power rule with rational exponents, or exponents that are fractions, nothing really different there. However, what happens if our fractions are hidden as radicals? So next we're just going to quickly review how to convert between radicals and rational exponents. All right, so here we have the 8th root of x raised to the b power. And if we wanted to convert this radical expression to a expression that has a rational exponent, it's just going to be x raised to the b over a power. Another way to think about this is that you might also have the rth root of x raised to the p power. So again, r stands for root, p stands for power. So the rth root of x to the pth power is going to be x raised to the power over root. So there we have it. The rth root of x to the pth power is x to the p over r. Now, how do I remember this p over r? Well, I happen to remember that p over r because p goes with r. pr represents Puerto Rico, so it's just x raised to the Puerto Rico power, and that's how that's the mnemonic device that I can use. If you have your own, please feel free to go ahead and use it. All right, so now we need to find the derivative of the following expressions, but as you can see, these expressions all have radicals. So step 1, convert the radical so that it is a rational exponent. All right, so before we actually take the derivative, we're going to rewrite these. So let's see, we have the square root of x. That means we have a power of 1 on the inside and a root of 2 on the outside for square root. So therefore, 3 times the square root of x can be rewritten as 3 times x raised to the 1/2 power. And then from here we can take the derivative, d dx of 3x to the 1/2 power. And then we can use the power rule, boom, 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 which is going to give us 3/2 x to the negative 1/2 power as the derivative of 3 times the square root of x. All right, moving on to letter b, we have negative 2 times the 5th root of x. So again, we can see that our power is 1 because there's no power stated, and our root is 5. So we could rewrite this as negative 2 x raised to the 1/5 power. And then we can come in and we can take the derivative of negative 2x to the 1/5 power. And we'll use the power rule. So 1/5 times negative 2. And then we'll subtract 1 from the exponent, which will give us negative 2/5 times x to the 1/5 minus 1, which is going to be negative 2/5 x to the negative 4/5 as our derivative. All right, moving on to letter C, we have 6 times the cube root of x to the 4th. We can see the power here is 4, and the root here is 3. So we can convert this to be 6x to the 4/3 power. Then coming down and taking the derivative, d dx of 6x to the 4/3. Using the power rule, 4/3 times 6 and then minus 1. And that's going to give us 24/3 x to the 1/3 power. And 24 over 3 is 8, giving us the derivative of 8x to the 1/3 power. Now we can look at letter D. Now, letter D is a little bit different because now we have a radical in the denominator. So we're going to have to take a couple extra steps here. But we can see our power is 3, and since it's a square root, the root will be 2. So I can rewrite this as 1 over 3x to the 3/2 power. But going back to a previous video, we can't have variables in the denominator yet because we haven't learned the quotient rule. So we need to somehow get this variable to be in the numerator. So we can do that by making the exponent negative. So we're going to end up with x to the negative 3/2 all over 3. And whoa, what happened there? So we can get x to the negative 3/2 all over 3, which we can even pull apart a little bit more to be 1/3 x to the negative 3/2. And then we can take the derivative, d over dx of 1/3 x to the negative 3/2. Use the power rule, negative 3/2 times 1/3, and then subtract 1, leaving us with negative, what's that going to be, 3 over 6x raised to the negative 5 halves, which will just be negative 1 half x, the negative 5 halves power, as our derivative. And all right, folks, that is it. That is extending the power rule to functions with rational exponents.